Let us understand what is Hive and how it works. Hive it got developed from Facebook and later contributed to the Apache Foundation as an open source project. Hive mainly developed targeting towards the people who are using the query language to analyze any structured data. Within HDFS, we may have all type of data. At some point of time, after doing all verification, cleaning and all the ETL process, the data would get converted into some structured form. We can verify whether the data is in structured form or not using a MapReduce code or using a pig script. Once the data is very well structured within the HDFS, I can use Hive and using the Hive query language, I can create tables, database and use the query which is very similar to the SQL and do the analysis. As such, HDFS will be used for the storage and Yarn will be used as a resource manager to execute any MapReduce code, and Hive internally it maintains a Metastore, that is what is the structure of the data and where the data is getting stored within the HDFS, what are all the types of the data, all that would get stored within the Metastore. Let us have a quick understanding on how the Hive is organized within our cluster. Let me get into the cluster environment. I do have the Hive installed. Within Hive, I do have the Hive server as well as the Hive Metastore server that's going to manage the metadata. Metadata in the sense, what is the structure of the data that is getting managed within the HDFS and which location the data is getting managed. A small example would facilitate us to get the better understanding about Hive. Let's get into the shell. Let us see a small example how to use Hive and create tables. And Hive provides a shell to access the content within the Hive that is called beeline. And the functionality of Hive is exposed in port 10,000 using thrift server in the machine where the Hive server is running. So Hive server is running in node 2. I'll be using it to connect using JDBC protocol to the Hive server 2 in node 2 port 10,000. A thrift server, that is an Apache open source project. We will be seeing about thrift at a later point of time. It will ask for the user ID password. Default user ID password is Hive. So I do have a database called MovieLens. And I can get into this particular database and check what are all tables available. I'm going to use the MovieLens database. I can check the details about this specific database. This particular database is maintaining the data for this particular database in this specific location within the HDFS. I can get into the HDFS. I can check that specific location. User, Hive, warehouse, movielens.db. So all the data specific to this particular database will be stored in this particular location. Let me go ahead and check what are all the tables available. So these are all the tables available. I can check more details about these tables. So the table movies is going to maintain the data in a specific location within the HDFS. We can identify that location where it is available. So these are all the informations about that specific table. So within this movielens.db folder, there is a folder called movies that's going to manage all the data. We can allow the Hive to store it in its own default location, or we can configure it to store it in a customized location as well. The data will not get verified or validated when it is getting stored. Let me get into the users. Here I do have the data. The data it would get stored as it is. The hash is the delimiter. That would be available as a part of the specific, the field delimiter, what it is, I would be configuring it. Let me go ahead and create a database and see how the data will be managed within the Hive and how to use the query. I'm going to create a database called movielens_demo. And this would create a folder in the default location within the warehouse. There will be a folder called movielens_demo.db. And any table that I'm going to create within this specific database would create a folder. Let me go ahead and use that specific database. Use show tables. I don't have any table now. I can go ahead and create a table. Let me go ahead and create a table called ratings. And saying ratings will have user ID, movie ID, rating and timestamp. Each row will be considered as a record and the fields will be terminated by hash, that is the delimiter for the fields. The table ratings would get created. Like that I will be creating more tables, that is movies, users and occupation. Now I do have this sample data that is downloaded from the MovieLens website, available in the local drive, and I can go ahead and make this particular data gets copied into the corresponding HDFS location of this specific table. Let me go ahead and do that. I'm going to load the ratings data into the ratings table. I can copy the data from the HDFS or from the local location. For the time being, I'm going to copy from the local location, and that would get copied into the folder corresponding to this specific table of ratings. Any file available locally within the node 2, I should be in a position to add it using the local command, or what I should do, I should add that specific file into the HDFS. As the HDFS is a common location, I should be in a position to add them quickly. Let me go ahead and add these files into the HDFS. I'm going to add ratings.t into the location mldata ratings.t. So this should get created in the home directory of the user with which I am operating. So it should get created within the root of the root location of HDFS. Here I should have the folder mldata under the user root, and the data would get copied into this specific location. It is getting copied. The similar way I will be copying the other data as well, that is movies.t, users.t and occupations.dat. I'll load all these 4 data into the tables. Let me go ahead and do that. Now I do have all these 4 files in the HDFS. I'm going to add that file which is available within the HDFS into the table that we had created. So what it would do, it would just move those files to the location where the table is maintaining the data. Let me go ahead and load this particular data into the ratings table. I should be giving that particular command within the B line. I'll load the data which is available within the HDFS location in mldata/ratings.t into the ratings table. Let me give the entire path. Load data in path which is there within the HDFS location, overwrite into the table ratings. If any data already existing, that would get overwritten. So what it would do, it would get moved into the location where the ratings table is maintaining the data. The data got loaded. The similar way, I will be loading the other table data as well. The movies.d data, I will be loading it into the movies table. Loading the users data, and let me load the occupations data. Now let me check what are all records available within the tables. For the test purpose, I am going to select the records from occupations. Select star from occupations. It will get me all the records available from the table occupations. These are all the records available. In fact, if I wanted to do the testing, I can very well do another query, ratings, that will count how many records are available within the ratings table. That's going to trigger a MapReduce job to get that particular query done. And we should be in a position to check the status of that particular job. So this is the job ID and different informations we can get. And the same thing should be available within the yarn URL as well. The MapReduce job got executed. This is the application that got executed, and we got the result, and I can check the result. There were around 1 million records within the ratings. The similar way, I can write whatever the query that I want. I should be in a position to use it by combining various data from the tables. So here I am going to select the occupations and count based on what are all the users that they have provided the ratings 5. And I am going to do the result based on the occupation. I am going to do the grouping. So for each occupation, how many users have provided the rating 5, I can verify. So this is a short example on how the query going to get executed and where the data would get stored. Irrespective of whatever the query that I am using, the data will be available within the HDFS in the location that we have marked as a part of HDFS. So I should be in a position to get into the Hive warehouse. I'm using the table. I'm using the database mobilence underscore demo. Where do I have the data for various? Here I do have the data for various tables. Here is the requested result for various occupation. How many users have provided the rating 5. So in a quick summary, Hive is going to facilitate me to abstract the complexity of writing a MapReduce code and work against the structured data. And the restriction with the Hive is it can work only with the structured data. So before providing the data with the Hive, we should verify and validate the data. That's where the components like MapReduce and Pig would come into picture. And Hive can work only against the structured data, and it doesn't have any capability to handle the error situation. It's going to use the HDFS for enormous amount of storage and Yarn for distributed resource management. And the Hive internally, it's going to generate the corresponding MapReduce instructions as and when required and get that executed on top of Yarn. So Hive basically, it is a data warehouse offering where I can do analysis on any structured data, and I will not be in a position to do any CRUD operation. That is, it is not an RDBMS where we will not be in a position to do row level operations like edit, or I cannot maintain transactions.